So in order to do this, I'm going to have to say for all n greater than or equal to 1, right? For this right here, unless I start this on 0, then this would work at 0. Okie dokes. And you're going to write down any questions you have, and then we'll have a little way for you to post that, and I'll try to answer those sometime during the day. So, since you can't talk back to me right now, let's try example 8. Here's how this one's going to work. In example 8, I would like to find a power series for ln of 1 minus x. Now, I think we can all agree that does not look geometric. I don't know how to write that out like we've been doing. But can I take the derivative of this, or can I integrate this to make it look like something else? And this says centered at x equals 0. That's always good. Makes things easy. So what is the derivative of this? Well, the derivative of that, let's do this together. Wouldn't it be 1 over the stuff? Yes. What do we have to remember? Times the derivative of the stuff. So that's going to be a -1. And lo and behold, that looks pretty much like a power series. Looks like a is -1 and my r value is x. So I'm thinking I'm going to go down here and I'm going to write this power series. So my first term would be -1, and I'm going to multiply times x each time. So won't that continue to be negative every single time? Minus x cubed plus ... What's our nth term? Well, we need a -1 in there, and then maybe x to the n. Now, I took the derivative of this to get this right here. So how do I get this back to this? I believe we call that integration, kids. So we're going to integrate both sides, right? If I integrate this side, can I sneak a dx in there? I can, because I have erasable pens. So we're going to put a dx right here. We're going to integrate this. If I integrate this side, let's think about that. Isn't this to the -1? So it would be an ln thing. And we would get ln of, well, it would be absolute value, but we'll get ln of 1 minus x, and then don't we have to divide by -1, which will take away the fact that this is negative, and we have positive, which is what we started with here. Alrighty, so if I integrated this to get this, I have to integrate this side. And we could do this with a big old dx on the end, but you get the idea. Remember, when you integrate, you get a constant. Let's just put that first. And then plus, well, is that going to be plus? Now that I look at it, I think that's going to be minus x. And then what? Minus x squared over 2, minus x cubed over 3, minus x to the 4th over 4, plus ... plus. Okay, how are we going to change this nth term? I'm thinking we can make this -1. What do you think? Can we just make this? Didn't we just subtract 1 from there? And aren't we dividing by n minus 1? And let's figure out, will this work if we put n equals 0 in there? I think it will. Why did I write a 1? Because that's how I do. There we go. I'm going to put that 0. Perfect. Okie dokes. Now everything is just completely understandable. You get all this, right? Right? Wait a second. What if we had to find that c? What can we use to find that c? Well, look back here. Our center was 0, meaning x equals 0. So if I put a 0 here for x, and I put a 0 here to infinity, what does that make our c? Well, wouldn't this be ln of 1 equals c? Because all of these are going to go to 0. And what is c? c equals 0. So we could rewrite this whole power series here and include ln minus x equals now. And remember, we can put in equals here because these are going to go to infinity the way we wrote this. All right, and so we'd have negative x minus x squared over 2 minus x cubed over 3 minus x to the 4th over 4 plus dot 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 plus our nth term, negative 1 x to the n minus 1 over n minus 1 for all n greater than or equal to 0. If they don't specify, you should always write 4 terms out right here, just so you know. And then I should have plus dot 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 3 dots, because for whatever reason, that's how they like it. Good? Okay. And because, you know, I can, we're going on to example 9. And this gives you this function, 2x 1 plus x squared. Aha. Well, if you had to, could you write that out, the first 4 non-zero terms and the general term of the series for f about 0? Now, this comes from a real old AP question. So this is the first part A, and I think this is something we can handle. What is our first term? I think we got good at this. The first term would be 2x. And then what is the r value? What would we multiply by each time? Well, this is plus x squared, so we're going to write that as minus x squared, because remember in the formula it's 1 minus r. So here we go. We're going to write that. So now to write this power series, we're going to start with 2x, and we're going to multiply times negative x squared each time. So 2x multiply it times negative x squared makes it negative 2x cubed, then minus, 2 times 2 now. Sorry, 2 times x, negative x squared is going to be 2x to the 5th minus 2x to the 7th. I think we're good, and we're going to write plus dot 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 plus and nth term. Do we alternate? Well, we should, so I need to go back here. That one, first one should be positive, that should be negative, this should be positive, right? And then that would be negative. That looks better. And we're going to put negative 1 to the n, and let's see, we're going to take 2. Does the 2 need an n on it? I don't believe it does, but the x does. So let's think about this. This is a 1, 3, 5, 7. So those are all odd integers. How am I going to represent that? Well, too bad I can't hear your responses, but I'm pretty sure I would hear everyone say 2n plus 1 plus dot 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 for all. Let's see if we start that on 0. Oh, looky there. I think we got it. So for all n greater than or equal to 0. Perfect. So in the real AP exam, this part of the question was worth 3 points, and that was a pretty easy 3 points. And here's how they break down. You get 1 point for having these 2 correct, and the second point comes from having these 2 correct, and then the third point comes from your general term or the nth term. So pretty doable for 3 points. Can you see all that? Okay. All right, let's try part B. In part B, it says, hold on, I'm flipping the paper. Oh, all right. Let the function be given by this. Does the series found in part A, when evaluated at x equals 1, converge to f of 1? Explain why or why not. We have 2 different ways we can do this. So let's look. If we wanted to say the sum of n equals 0 to infinity of our nth term, so we got negative 1 to the n, 2 times x to the 2n plus 1, for x equals 1, remember that's what they're asking us about, if the function is going to be the same as the series here. Well, to do this, we're going to let x be 1 in our series. So we would have the sum as n goes to 0 to infinity. And if we put a 1 in there, we have negative 1 to the n. We have 2, and this would be, hold up, wait a minute, x is 1, 2n plus 1. So now, how do we show if this converges or diverges or not? Well, we got to think about this, don't we? What's going to happen here as we let n increase? Isn't this going to be a 1 all the time? And so don't we have this guy, n equals 0? We have this going on. This is actually a 2. So that is an alternating series. And in order for an alternating series to converge, one of the criteria is the limit as we go to infinity has to equal 0. Well, what's this limit going to be? This is always going to be, if we took the limit, and remember if we're doing alternating series, we're just going to think about this as n goes to infinity. This is 2. That is not 0. So now I can say that this guy diverges, but not by alternating series, right? We just did the alternating series test, but we're going to say, I have a little space here, we're going to say this diverges by nth term test. So now, that is one way for us to determine convergence, divergence. And as promised, I said there's 2 ways. So let's investigate the second way you could have done this. You could have noticed that our function, oh, wait, let's come to a conclusion here. This diverges by the nth term test. So the series does not converge to f of 1 at x equals 1. Sorry, we had to come to our conclusion. So that's one way we can come to that conclusion. We let x be a 1, and we saw that this diverged because the limit wasn't 0. It was alternating. We tested the limit. It wasn't 0. Diverged by the nth term test. Or we could have done this way. We could have said that this guy, 2x over 1 plus x squared, is a geometric series. With, what do we have to look for in geometric? Absolute value of r equals the absolute value of x squared, which is the same thing as the absolute value of x squared. We put that less than 1, and we'd get x is less than 1 and x is greater than negative 1. So our interval of convergence, remember, would be negative 1 to 1. Well, those are open parentheses, our interval of convergence. Remember that? Sorry. Those are open parentheses. Is 1 included? No, it is not. So series converges on this open interval. X equals 1 is not on interval. So series diverges at 1. Again, either this way or this way, when you do it this way, you had to mention that this was geometric series, and that's how you knew, because this fit the criteria for a geometric series with its R value and all the other things. Okie dokes. Now, whew, here we go. This is going to be the fun part.